All right, let's get started. A couple of quick reminders. First off, and this isn't even in my slides for today, but there we go. Well, I guess this is part of it. So first off, I want to always remind you of this detail. What is math? Study of patterns and relationships. And so we are becoming mathematicians. Oh yeah, Kylie, you need a group too, don't you? And Allie is not here at all, so jump over here to group, what is that, 5? Yeah. There we go. Okay, so it's the study of patterns and relationships, and we're becoming mathematicians, so what do mathematicians do with patterns and relationships? They notice them,
gather,
they describe them, and then they generalize them, right? Which is one of those things that we need to start developing our vocabulary so that we can describe and generalize them. All right, so we're going to look at some rubric reminders. Just a heads up, if you didn't already see it, there are a handful of people I don't have emails for, but I sent out a newsletter yesterday. I sent one to your parents with a Google form for them to fill out, and I sent one separately to you all so that you could see the newsletter as well. It's a total of 4 pages. One of those pages is literally all pictures. Another page is half pictures. So if you want to read through it, it might help you understand how we're going to do things in this class. I would recommend that. Secondly, I sent, if I had yours and your parents' email, or at least an email for you and an email for your parent, which I have TCSS emails for everybody, I sent you the Google Sheet that I'm uploading your active collaboration score every single day. So please talk to your parents, make sure they check their email, 1, so they get the newsletter, 2, so that y'all see your active collaboration scores, right? Because if you need to know how well I see you participating, because if you're not participating well, you need to be aware of that so that you can change your behavior, so you can improve your growth and understanding. And if I don't hear back from your parents on those newsletters, I'm going to email them again by the end of this week. And if I don't hear back from them after that, I'm going to start calling parents. So that's more work on me, and I assume, I don't know, it's actually not a bad call, but I assume you don't necessarily want me calling your parents all the time, and I assume your parents don't want me calling them, taking up their time. I'm more than happy to, but it's easier if they check their email, if they respond to that Google survey. So just say, hey mom, dad, whatever, check your email for an email from Mr. Kinney. If they didn't get it, I need to know that so I can get a different email or something to that effect. After that, we're going to look at our graphic organizer that we're going to be using throughout the semester as we examine the homework to establish fundamentals. All right, I'm going to talk about that in just a second. We are going to take at least half an hour or so on lesson 1, understanding concepts of linear functions, looking at the idea of inverses and translating among relationships. This first lesson here is going to wrap up all of our introductory ideas on that graphic organizer that you have, this one that we started to look at yesterday, right? So be aware of that. Now, remember, here's our active collaboration rubric. The scores that you earn on the Google Sheet are not just scores, there's feedback with it, right? If you're looking, which there's only been a handful of 0s to 2s, but if you're looking at 0 to 2, we need to pick it up, right? You can't learn if you're disengaged, you can't learn if you're not doing much in class, you can't learn if you're distracted by your smartwatch, you can't learn if you're sleeping. I can't do anything in those situations. If you're in the developing, you're getting better, you're okay, but really what score are we shooting for? 4. If you're engaged, right, you're sharing your thoughts, your insights, and or thoughts about the presented problems or mathematical concepts, right? So you're sharing what you see to those in your group, but you're also listening to and considering others' thoughts and perspectives. As you talk about things, you will learn them better. And as you talk about things, you'll be less bored. I am tired of hearing students be like, oh, Mr. Kinney, you're so boring. No, you're boring. You're not doing anything. That's not to call anybody out in this class, as I haven't heard that yet, but I'm sure I will throughout the semester. So please be aware of that, right? When you talk, it's going to make it more fun. It's going to make it easier to deal with. You'll learn more, all right? During whole class discussion, oh, and then you need to be asking questions of each other's thinking. Whole class discussions, remember, we're looking for actively sharing thoughts, asking questions, or taking notes. To be engaged, you have to hit 2 of those. And that doesn't have to happen 100% of the time, but at least 75%, right? And if you want to, you can shoot for those 5s. I've already got several people who are scoring or averaging over 100% on these active collaboration. That's easy grades. You got to engage. And when you engage, you'll learn more and you'll do better on assessments and things like that. So that's our active collaboration rubric. If you turned in that blue homework on the Desmos activity, I know there were some struggles. We're going to talk about some of those things in just a second. But remember, this is the rubric, right? It's not just random numbers or numbers and letters at times. And I will say I mixed some of the D's for significant details down into the 4s. I brought the C for conceptual errors up into the 4.5, and I even used some of the letters on the 5s. But if you're looking at a 5.5 or a 6, there's clear, consistent, convincing evidence of your conceptual and or procedural mastery. Meaning, conceptual, you understand the concept at play. Procedural, meaning you're able to do the work that you need to do. If you're looking at 4.5 or 5, that's still pretty good. There's still evidence of your understanding. If you see a 3.5 or a 4, you need to be aware of that because that probably means you have a major conceptual error or you're missing such important details that I couldn't put you into the clear evidence, or you're making major procedural errors, right? So if you're in that 4, you need to be aware of that, right? A 4 and up means that your answer is correct or valid, but there's degrees with how well you understand what's happening there. A 3.5, maybe part of it's valid, but part of it's not. If we are in the -1 to 3, that's where we really need to be talking with our peers. You need to be asking questions and collaborating, engaging. All right, so remember, those scores mean something. It's not random. All right, from here. So one of the things I want to talk about first, when I looked at this, and I have notes to myself so I don't forget anything, and this is always an issue every single year, and I get it somewhat. I need you to be aware of this issue. There's always going to be someone who has the same answers as somebody else. If I see that, that's plagiarism. Can you collaborate and talk with other people to help each other understand better? Yes. Should your wording and work be exactly the same? No. That means you are looking at each other's paper. I don't know who copied from whom, but if you have exactly the same work and exactly the same phrasing, I know that you just looked at each other's work and there may not have been discussion. You can talk through ideas, right? And when you talk through ideas, you will help each other understand better. I'm totally on board for that, but the work should not be exactly the same because you talked through it, you didn't just look at each other's work. Now, if you are one of those, and I had some from this class, I had some from my next class, if you were one of those who I made notes about plagiarism and so you're getting a 0 or something to that effect, be aware, I always have more homework grades than I need. In a college class, a lot of times what professors will do is they'll drop your lowest homework grade or 2, depending on how many you have. So like if I have 20 homework grades, I'll probably drop 2 to 3 of them. So as long as that plagiarism is not an issue into the future, I'm not going to report as academic misconduct, I'm not going to reach out to parents, I'm not going, and that grade will get dropped at the end of the semester, or end of the 9 weeks. Alright? So learn from your mistakes, grow from them, and get better. We will make mistakes. That's good and that's okay, but we have to change the way we're operating. Any questions about that before we get going? Okay? Secondly, I saw a lot of people who said, hey, Mr. Kinney, I have no clue how to do this, or I saw a lot of people who had ideas down but did not tie in to what we were supposed to do. Guys, please follow the directions. You should have read the question first in the first column, because the work that's in the second column is trying to answer the first column. So when I looked here, and we did this on Monday, we were trying to solve this equation, right? And when we solved that equation, or the work that was shown here, we got x equals -7, and then we had the tips for checking the work in Desmos. Type the entire equation as shown in Desmos.com. And does anyone remember what we saw when we typed that equation into Desmos.com?
A straight vertical line.
A vertical line. Where did that vertical line go through?
On the 7 axis. I mean, yeah.
It went through the x-axis at what x value?
7.
Close.
-7.
-7, right? Whoops, that is not going through -7 because I'm struggling today. There's -7. And what did they say the solution was? X equals -7, right? So did that confirm that the problem was correct?
Yeah.
Yes, right? That's the whole thing, is that when I looked at that graph, I saw x equals -7, so that confirmed my solution and the work that I saw in numbers 1, or the first and second column. A lot of us got distracted by this question here of what do you notice and what do you wonder. The point of that was to help you answer this: is the work for this problem correct? This was the directions for this column. Is the work for this problem correct? If so, how does Desmos help you? If not, fix the mistake. So what do you notice, what do you wonder, to answer this question? I didn't want you to just write out what do you notice and what do you wonder. Can you let them in? Okay? Did some of us misunderstand those directions on that? Yeah, we did. Okay. So I need y'all to hear me on this. When there is confusion, thank you, sir. When there is confusion, what should you do? Email. I didn't have a single person email me. If someone had emailed me, I would have changed up Monday so that we could have done some of this in class, and I would have had you turn it on Tuesday. I can't change things if I don't know. I thought the directions were clear. That's my bad. Yeah, Gerald, right? I started moving students around because we were missing. Grab a laptop, jump back into group 6 so that we have people to work with today. I think your homework sheet is on the desk, isn't it? That blue sheet? Is that yours? Does it just have your name on it? What name is it?
Or something like that.
Oh, Metria? Okay, never mind. So you never turned yours in. Get yours out. Okay, so you know what's on it. Okay, well then right now you're going to have a 0 in the grade book. I'm going to talk about it. Just hold on, okay? Hold on, okay? So again, hold on. Do you trust me? Okay? I know some of us have struggled, but have I looked out for you this whole time?
Yeah.
Alright, I'm always going to look out for you. I care about you. I care about your education. Just hold on. Alright? A lot of us struggled, so I got to take that into account. So, reach out when you have questions. If enough students, right? Not just 1 or 2, but if like 3, 4 students. Notice that's not many. I teach 63 in a day. All Algebra 2 is stats. If 3 or 4 of y'all had reached out, I would have started to realize, hey, there's some confusion here. Cool, let's handle that. Gerald, please put your headphones up. Thank you. So reach out, and I'll be more than happy to help you. Hopefully, does this explain the directions a little bit better? Okay? Now, I will point this out. These are the same exact instructions I gave last Thursday. How could you have found those verbal instructions again? You could have gone to YouTube, right? If you're running into confusion, I addressed some of those things in class, posted a video about it on YouTube. I'm recording it right now, so I'm going to go ahead and tell you this. We struggled on this. Well, I don't want to just abandon you. I don't want to make this really hard. Yes, this was a homework assignment. I'm going to reduce the number of points that I originally made it. I'm going to make it a 10-point homework assignment based on however you did. We're going to work on it in class today. And then I'm going to give it back to you, and it's due to me back on Friday, where we correct our mistakes. I'll give you a blank copy later today. I'm going to print some out. That redo, since you're having more time on it, is going to be a 20-point homework assignment. So we need to take it seriously.
So when you correct it, you basically, it's going to be different? The one that you print out is going to be different?
No, it's the exact same homework. So like if you earned a 6 on something, you're already good to go, right? If you earned a 3.5, you already know that you're somewhere in the ballpark, right? We need to work on it together in class a little bit. But you know that what you need to improve upon. And you'll notice, did I just put scores on your homework assignments? No, what else did I do?
So
I didn't tell you exactly, but I gave some feedback. I gave you some notes to improve your understanding. If I don't have your homework, I can't give you feedback to improve your understanding. I can't help you progress forward in your understanding, right? So I need you to turn in your homework. I need you to try it. If you have questions, email me. Remember, you can go to YouTube. I also have 4 tutoring sessions every single week. Monday, Wednesday afternoons, 3:15 to 4. Tuesday and Friday mornings, 7:20 to 7:55. I'm here to help you. And it's up there if you ever forget. So please take advantage of those. So let's look at a couple of these together. Let's look at a couple of these together. So go to Desmos. We should already be there. Click on the graph. I don't remember exactly what it says. There's something there about graphing calculator. That one, okay? So we got our graphing calculator there. From here, yes ma'am.
You got to log in,
You can't log in?
I'm sitting over there trying to.
Okay, so make sure you go by the office. That should log in. Okay, so when I look at this for number one, some of us do need to improve what we wrote. We did not pay attention to exactly what I said. Maybe we need to go to YouTube and rewatch number one. But what should I do for number two?
Type
Type
it in.
Type it in, right?
Yeah.
2x squared minus 5 equals 27. By the way, does that equation look familiar?
How do you do square?
Okay, so there's two ways to do squares. One, the caret symbol that is above the number 6, that creates an exponent, so you have to hit shift and then 6. Yes, sir.
I need help getting into Desmos.
To get into Desmos or to log into your computer?
I'm logged in.
Just go to Google or Safari and then search for Desmos.com. Right?
And then click
Do you still have your blue homework sheet? Because that's what we're working on today. Okay? So does this equation look familiar besides just it was on the homework? Nobody? 2x squared minus 5 equals 27?
It was
That was the bell ringer yesterday, right? So we already know. What were the answers? Does anyone remember off the top of their head? X was equal to 4 and x is equal to negative 4. So I want you to notice when you look at the work for number 2, does it say x equals 4 and x equals negative 4?
No.
It just says x equals 4.
But we know
Look at that graph. How do we know it's 4 and negative 4?
because it goes across the
Cause and in parallel.
So does the parallel lines matter whether it's x equals 4 and x equals negative 4?
Yeah.
So, is that a great observation, something you noticed? Yes. But remember the question is, or the problem is, solve this equation.
It's already solved.
Is, but is it correct? You sure about that? What does it say in the second column is the solution? X equals what?
4.
Okay, look back up here. Or look at your laptop. If you have 2x squared minus 5 equals 27, is it just x equals 4?
Oh.
So is there an x equals 4? Heck yeah, right? But what else do we have there?
negative.
X equals negative 4.
So the answer would be correct, but there's also what we have.
So technically what I would say is the answer is incorrect.
No.
It has,
Okay.
because here's the thing. It has one, what is the term for the value that makes the equation true? The value that makes an equation true. Talked about it yesterday.
A mathematical statement.
Well, that's an equation or an inequality. What makes that mathematical statement true? Maybe we need to get out our graphic organizers. We'll be using it today. Say it one more time. The solution, right? We're trying to solve, which means we're trying to find the solutions, the things that make the equation true. Right? So Savannah, they have one solution,
Okay.
but there is a second solution. So is their answer correct?
No.
That's the issue, right?
Okay.
So even though they have one solution, there's two solutions, and so the answer is incorrect.
Can we make notes somewhere?
Heck yeah, put it on that blue sheet of paper. Put it on your graphic organizer, right? Not can I, you should put notes, right? I'm trying to give you some help to help you do better on this the second time around.
It didn't work.
Huh?
It didn't work.
Okay. So while people are getting some notes down, and I might have just mistyped. There you go.
Thank you.
Mhm. So, that's just one way. So I want you to notice, this is how we can use Desmos to check our answers when solving an equation, right? That's something here, but there's other things that we can use Desmos to check, which is what the rest of the problems are about. I think that's it. Oh, I lied. The blue sheet is going to be due next Tuesday because I have the graphic organizer due on Friday. So make a note to yourself that the resubmission of this blue homework assignment is due on next Tuesday, which would make it the 18th. I'll show you the homework that's due on Friday at the end of class. All right. So I will point this out. Look at your graphic organizer. Does the term solution or solve show up anywhere?
Yeah.
Yeah? Which one? Where does it show up? The second term or concept, right? So, we've talked through the idea of what a solution is here. I haven't formally written the definition on the board, but you should have a better understanding of what a solution is. You should be able to reference this homework assignment on that graphic organizer to improve your understanding and come back to it, right? The problem in column 1 says solve this equation. That should give you an understanding of what solve means. Solve, find the values that make the equation
True.
true, right? Find the solutions. So those are things that I need you to understand. Trying to think. Did we talk about why it's +4 and -4 yesterday?
Yes.
We did? What was the reason?
We get a square root.
Okay, so why did the square root require positive and -4?
Because it's exponent.
Partially, okay, but here's the thing, alright, so what did we do first to solve this equation? 2x squared minus 5 equals 27. Okay, so they had that work correct on the sheet, didn't they?
Yes.
Yes. And why did we add 5 again? So we're gonna talk about this more heavily.
To get rid of the, well,
To get rid of that one.
that, to get closer to the x, so you can.
To get x by itself.
Okay, so we are trying to get x by itself, but why does adding 5 get us closer to x by itself?
Because it's taking out.
You have to cancel out.
It does cancel it out, but I want to tell you this, and this is something we need to work on. Cancel out is not a mathematical term, and that's important because it's not going to help you fully understand it. So I'm going to continue on. I'm going to come back in a second, and I'm going to show you why it's important that we don't just say cancel out. What would I do next to solve this equation?
Divide by 2.
Divide by 2, okay? So why are we dividing by 2?
Because you're trying to win.
You're trying to get the x by itself.
Okay, so dividing by 2 what? Does what?
Gets the x by, or puts a 1 right there.
Simplify.
Okay, we are going to simplify, and when we simplify, we're going to get a what?
A 1.
A 1. So I want to point out, that's closer to what we should be saying. Most students here would say that the 2's cancel each other out.
What are you asking?
I'm asking, why are we dividing by 2?
Inverse?
Okay, that's a big, big, big part of it. Yes, sir.
What did he say?
He said inverse. Because what's the inverse of multiplication?
Division.
Division, right? So what I want us to understand is, a lot of students would just cross these out, right? Indicating that they are what?
0.
There's a C word that y'all have already said today. Say again, canceling. This is why I need you to understand why we don't want to say the word cancel in this class. It's going to mess up our understanding of the math that's happening. So you're saying that this is canceling, right? And then you're saying that this is canceling.
No.
But that's what y'all said earlier, isn't it?
But it's the inverse, putting a 1 right there.
So 2 divided by 2 is creating a what?
A
A
one.
1. But what's -5 plus 5 creating?
A 0.
That's important, right? Most students, a lot of students see both of those as canceling, but they're not just canceling, they are inverses, either creating a 0 or creating a 1, right? Notice, what is 2x squared minus 0?
0.
No, 2x squared minus 0.
2x squared.
2x squared, right? I created a 0, so I got closer to 2x squared. I divided by 2 to create a 1. Hey, what's 1 times x squared? 1x squared. So x squared, right? And then we started talking about it yesterday, the inverse of a square. Notice after you say the word inverse, the thing that undoes a square is a square root. Now, remember, we're trying to find what makes that equation true. So, I think everyone would recognize, hey, x is equal to 4. You can even plug it into a calculator and get x equals 4. But I want you to go back and I want you to think about it. Yes, 4 squared is equal to 16. Is there anything else I could square to get 16 though? A -4. What do you think?
I had one answer.
You say 8? Yeah, it's okay. But if I do -4 times -4, will that also give me a positive 16? So that's something we need to be aware of, is that when I take a square root, it's not just going to be a positive 4, it's also going to be a -4. It's when I take that square root that I have to recognize that it's both positive and negative. And I will point this out. If you went to Desmos and you checked your answer by typing that equation in, would you see the evidence that it's supposed to be positive and negative 4? Would that help start to trigger something so that you don't forget in the future? So we need to use Desmos to help check our answers at home. Okay? This is going to help you grow and learn if we take advantage of this. Now, I do want to quickly point out, you do not always do positive and negative. There's only certain situations, which is why you also want to check Desmos again. What I mean by that is, hey, let's say I have x cubed is equal to 8. What's the inverse of a cube?
3.
The inverse?
So the inverse of a square was a square root.
A cube root.
So the inverse of a cube would be a
Cube root.
cube root. Now remember, with a square root, I'm asking, hey, what multiplied by itself gets 16? With a cube root, notice there's a 3 there. I'm asking what multiplied by itself 3 times gives me 8.
Nothing.
Nothing? I can't multiply anything by itself 3 times?
Oh, yeah.
Yeah, so what's the cube root of 8?
2.
2. Now, I want to point this out.
Oh.
Could it be a negative 2?
No, because you got 3 of them.
And if it's 3 of
It's a
them, that's
negative.
going
It's
to be...
gonna make it a negative.
Oh.
Negative.
So notice, it's only, we'll go into more detail about this in the future, it's only when it's an even root, so a square root, a 4th root, a 6th root, that'll be positive and negative. If it's an odd root like this, it'll be whatever's under the symbol. Because if I had x cubed equals negative 8, what multiplied by itself 3 times would give me negative 8?
Negative 2.
Negative 2. Okay. Some of these details I'm just introducing to you so that we have background information for the future. But I'm going to give you time because like some of us have been engaging and talking, a handful of us have been writing down, but some more of us should definitely be writing notes down for number 2. So I'm going to give you a few seconds to write some notes down for number 2 so you can do this better on your redo. Okay, so write some notes down so you can do this better on your redo. Yes, ma'am. Well, I was going to open up questions for the whole class in a second.
On this one, it say 24. But on here, it say 72.
So that means someone made a mistake, right?
I,
The work doesn't have to be correct. There are 4
So-
columns.
also, the word can be wrong.
That's the whole point, is that we're using Desmos
Read.
to check to see if the answer is correct.
It says 4 of the problems below are going to be incorrect.
Okay. By the way, I'm printing out extra copies of this homework sheet so that you can write notes or do your corrections on there, and we'll talk about that in a second. Okay. Are there any questions that we want to ask about number 2 before we move on? Because we have confusion still. Going once, going twice. Sold. All right, number 3, okay? So I'm not going to do nearly as much time on number 3 because I want y'all to work on these things together. But again, a lot of us did not follow the directions. What are we even trying to do on number 3?
Plug 2 problems in.
Say again?
Plug 2 problems in.
What do you mean? Look, I mean, so first off, which column should I be looking at to figure out what I'm trying to do? The first column, right? What does it say?
Find 4 that H, -4,
Find H, and then what'd you say?
-4.
What, okay, so I'm gonna go out on a limb and say, how many of us know how to read this statement or what this statement means?
That,
H is multiplied by -4.
Okay, so we need to talk about that, because that is what a lot of students do think. And so here's what I need you to understand. Part of this assignment was also to figure out what you know about this detail. I want you to look again at the second column though. Did they multiply H times -4?
no, it means H is -4.
Not H is -4.
X.
X. Remember, what was the equation? H of X equals,
Negative,
3x squared plus 2x minus 16.
there we go, right? There's the equation. What did that -4 take the place of? X.
Oh, so you just plug it in.
Right.
So to be H, you put it in.
And look at the second column. What did they do with that -4?
They plugged it in.
They plugged it in for
X.
X. Okay. Now I will say there's a slightly more technical term with mathematics of substitute, but notice that's what they did. They took this -4 is taking the place of X, so they substituted that in. Now, really quickly, this is called function notation. Why do I say it like that? This is function notation. It's on our graphic organizer. Go look at your graphic organizer. Did I give you a graphic organizer? Did I give you all the rubrics for this class, like the pink and green sheet? My bad. You weren't here yesterday, were you? That's why you need a graphic organizer. This is what I'm referring to. Yes, ma'am. The graphic organizer. Was anyone else not here yesterday and needs the graphic organizer? Remember, when you miss a day of class, you gotta tell me so I can figure out if I need to give you anything.
So we're getting our graphic organizer?
Yeah, because what term is on that graphic organizer?
Function notation.
Function notation, right? So we need to make some notes about function notation. Okay, so function notation is this piece right here. If you ever see h of x or f of x or, I don't know, g of t, first off, I want you to notice, am I saying that those things are being multiplied? No. I read it as, and you might want to write this notation down, that is f of x. That's how you would read that. Because how many variables do we have for our functions?